All of you to Animats. In today's video, we shall be taking up factorization part 2. Okay, so in factorization part 2, we shall be taking up factorizations based on three identities on the whole. The first one is a plus b whole square, the identity a plus b whole square. The second one is a minus b whole square, and the third one is a square minus b square, that is difference of two squares. So these are the three identities on which today's factorizations will be based on. Okay, so watch carefully as I explain it. Remember, these are not expansions. We are not doing these expansions of these three identities. We are taking up the factorizations which are based on these identities. Okay, so let's see the video and you will know what is the difference, what it is. Okay, so we are continuing with factorization today, as said. Now this is the next type of factorization after we did factorization of groups. Okay, so here I will write a sum and we'll try to figure out, this sum is based on an identity. Okay, p square plus 24p plus 144. This sum is based on an identity. Now by looking at the sum, you should be able to guess the identity. Okay, the identity is a plus b whole square. Okay, so if I write here a plus b whole square, that is equal to a square plus 2ab plus b square. Now we can clearly see that this sum is following this identity. This expression is exactly like this. That is, it is having a square term, b square, 24p, that is, this is a square term which is b square, and 24p can be written as, let's see how, p square plus 2. Here I have a 12 square, 144 is a 12 square, 2, and then we'll write the p, and then we have the 12 from here, so the 12, and so 12 into 2, 24. So here we have 2ab or ba, whichever, it is the same thing. So we have 2ab plus b square. Now this one is given to us. Now this is very important to understand. It has been given to us in a expression form. Okay, that is in the expanded form. That is in this form. From this form, we are going to this form. Okay, so we are going to the factor form. In other words, we are factorizing this expression. So this is an expression to that. From that, we are going to factors. So here it is p plus 12 square. Okay, so p plus 12 square, a plus b whole square. Now this is clearly a factor. Why is it a factor? Because it is p plus 12 into p plus 12. So we have converted this expression to factor form. So as I have told, this side to this side conversion is factorization. This side to this side conversion is expansion. So expansion is the opposite of factorization. Okay, I'll just make a box. Don't mix this up with the rest of the sum. And you can write it at the side of your notebook or at the top of your notebook. This will not carry any marks. Only this much will carry marks. Okay. Now let's take up another example. Very similar one. The numbers are slightly bigger. 16. Then 16 x to the power 4 plus 9y to the power 4 plus 24 x square y square. Now that gives us, if I write this, now here also you will have to see it and understand that you have to recognize the identity on which it is based. So it is a 4x square square plus 3y square square plus 2 into 12. Okay, 12, I shouldn't write 12 here. I'll make it 2 into 4x into 3x. Okay, 4x square into 3y square. That is what gives me 24. 12 into 2, 24, 4. So I have the 2ab term here. I have the b square and I have the a square. Now remember one thing. Here it is, the a itself is a square. So not to be confused. Okay, then we have, if we have We can now write it in the factor form like this. Okay. So 4x square plus 3y square. So we have converted this to the factor form. So we have factorized this expression to this. Okay. All based on this identity. Do not mix up. We'll take up next again based on sums based on a minus b identity. Let's see how they are. So the next one is a square minus 4ab plus b square, and this one we are going to factorize. Okay, this is expression given to us, we are going to convert it to factors. Okay, 1 minute, I have made a small mistake. I need a 4b square here. Now this is again based on this identity, which is a square minus 2ab plus b square. If you note clearly, this is my a square term. Here I have a 2 hidden and a and then a 2b, and this is a 2b square. Okay, so this is my formula. This we are just supposed to see this and follow this identity and then do the sum. Okay, so here I have 2b square. This is my b term according to the formula, and the a here is a in the sum too. So a minus 2b whole square. So we have factorized it. So this was a sum which was based completely on, it was based completely on the identity a minus b whole square. Let's take up another one, little big. 16a to the power 4 minus 72 a square b square, and then plus 81 b to the power 4. This is 4a square and a 4, and this is a 9b square and a square minus 2 4a square and 9b square. Okay, so this is my final. I have expanded it like the identity, like this identity. Okay, do not mix up the two sums. So here I have a square minus 2ab plus b square. Next what? 4a square minus 9b square and a square. Okay, so I have converted it to factors, but then there is something still to be done here, because this is already in I have done it in factors, but it can still be written like this, 9b square and one more. You'll see why I am doing this. I have split this. Now in the previous sums I didn't do, but here when I saw that here it is, this one is difference of two squares, then I had to do this, because now I am going to do 2a minus 3b, 2a plus 3b. For this bracket I use the identity a square minus b square. Okay, again for this bracket 2a minus 3b, 2a plus 3b. Okay, so I have got, now this is the final factors. Why I didn't stop here is because I could have further split it into more factors. Okay, so now I have got the final factors, which is 2a minus 3b from this one and 2a plus 3b. Which identity did I use for this? I have used this identity. A square minus b square is a plus b into a minus b. I have used this. Okay. So this is my final factorization. Your factorization is incomplete if you do it till here. Now let us see how we are going to take up more sums based on another identity, which is a square minus b square. That is sums completely based on this identity. Okay. Here we have a plus b whole square minus 64. When they write like this, a plus b whole square minus 64, what to do? We have, it is based on the identity it is based on this, a plus b into a minus b, that is equal to a square minus b square. It is based on this. Okay, so now we are not supposed to open up. In most of the cases, people open this up. That is a wrong thing. You should not open it using a plus b whole square. You will be in more trouble. A plus b whole square minus 8 square, a plus b minus 8, and or you can write plus 8, a plus b minus 8 over. That is our sum. A plus b plus 8 and a plus b minus 8. Factorization has been done. So without opening this, please don't open it. If you open it, you will not be able to manage it. So this is a square minus b square. So I wrote it in the form a square minus b square. Let's take up another question. Little bit of fractions is there. Okay, now what is this sum? This is 4 by 81 minus 25x square. 25x square. Now this is 2 by 9 square minus 5x square. Okay, that gives me 2 by 9 plus 5x and 2 by 9 minus 5x, sum over. Okay, so we have a square minus b square, a plus b and a minus b. Let's take up another small question which is very much prone to mistakes. That's why I'm taking up this question. A to the power 4 minus b to the power 4, which is a square minus b square. Write it like this. Okay, so this is still difference of squares. A square minus b square, a square plus b square. I have used the identity once. But then if I use the identity once, I can see one of them is having sum of squares, another is still having difference of squares. As long as the sum has difference of squares, I have to keep on and on splitting it. So a plus b, a minus b, a square plus b square. That is my final answer. So unless you do this step, you do this splitting, you have not completed the sum. Okay, so we'll stop here today, but we have lots and lots of more varieties of this particular identity, that is difference of squares. So I think I'll need a full video on only difference of squares. So my third video on factorization is going to be solely on difference of squares type of sums. Okay. So till then, keep practicing and do not forget to like, share and subscribe if you like the video. Okay then, bye all of you.